What is going on, YouTube? Just helping you out here. And for today's video, I'll be doing Chapter 15, Problem 40 in the Fundamentals of Physics textbook, 8th edition by Gerald Walker, Halliday, and Resnick. Chapter 15 is all about oscillations, and in Problem 40, we are trying to find the length and maximum kinetic energy of a simple pendulum. And so for Part A, that is where we're trying to find the length. And so we know that the period of a pendulum is equal to 2 pi times the square root of length over gravity. And we also know that the period is equal to 2 pi over the angular frequency. And so what we can do is we can set these two equal to each other. And we have 2 pi over omega is equal to 2 pi times the square root of L over G. And so now what we can do is we have 2 pi on both sides, so we can cancel those out. And then what we can do is invert both sides, and so we get omega is equal to the square root of G over L. And then we can square both sides, and so we get omega squared is equal to G over L. And then we can solve for our length by rearranging, and we get L is equal to G over omega squared. And the problem gives us both of those values, and so we have 9.8 meters per second squared divided by 4.43 radians per second squared. And if you plug that into your calculator, you should get that the length is equal to 0.499 meters. And so that's it for Part A. So now for Part B, we're trying to find the maximum kinetic energy, and so we know that K max is equal to 1/2 m times V max squared. And we know that V is equal to negative omega xm sine omega t plus phi, where omega is our angular frequency, xm is our amplitude, t is our time, and phi is our phase shift. And in order to find V max, this term right here needs to be -1, and so that's going to leave us with just omega times xm. And since we are working with a pendulum and working with the amount of a circle that's been swept through, we would prefer to write this in terms of an arc length, and so this is equal to omega times L times theta m. And so we have all those values, so we can plug them right in. So V max is equal to omega, which we are given, 4.43 radians per second. Our length, which we just found in Part A, 0.499 meters. And finally, our theta m, which is also given in the problem, so times 0.08 radians. And if you plug all of that into your calculator, you should get that V max is equal to 0.177 meters per second. And we also have our mass, which is given in the problem, but it's given in grams, and we would prefer that in kilograms. And so our m is equal to 60 grams, and we know that there are 1,000 grams in 1 kilogram. And so our new mass is 0.06 kilograms. And so now we have everything we need to plug into our kinetic energy equation. And so K max is equal to 1/2 times 0.06 kilograms times our V max squared, which we found right here. So 0.177 meters per second, that entire quantity squared. And if you plug that into your calculator, you should find that K max is equal to 9.4 times 10 to the -4th joules. And so that's about it for this problem. If you found this video helpful, please drop a like, leave a comment if you have a question or an idea for a future video, and lastly, please don't forget to subscribe and tell your friends about my channel so I can grow and help more of you guys out. I'm just helping you out. See you in the next video.